All right, solids, liquids, and gas, states of matter. We're going to start here. For us, it's going to go a little bit different than it has in the other classes. We're going to take notes very quickly. I'm going to put the notes on the anchor chart, which are already over here. Some of you can see. And then we have to go back and watch the videos because I can't play the videos because of copyright law. So let's go through this really, really quickly. We'll watch this later. Again, I highly recommend this. I feel like somebody could watch this and probably at least make a 70 on the test if they just paid attention to this Study Jams video, which we will come back to when we finish this. All right, first, and this is the first definition we will take for today, is matter. Matter is anything that has mass and takes up space. And for us in here, solids. Solids have mass, solids take up space. Liquids have mass, liquids take up space and the shape of their container. Even gas has mass and gas takes up space. We'll talk about all those when we get to these things, but matter is our first vocabulary word. And looking at the vocabulary that I'm going to pass out in a few moments, it is the first vocabulary word on your vocabulary packet this week. I know the first thing you're going to say, Eloise, you're going to look at this, you'll be like, oh my gosh. Mr. Bullens, there's like 8 pages of vocabulary things. There are 20 words that we should be doing this week. I broke it into 10 this week and 10 next week. I know that there are a lot of activities. I need you to get these words in your brain. And it is very difficult when you talk about gas to liquid, liquid to gas, solid to liquid. All of that sounds very similar. And it is a lot of words that you have to memorize. So I do want you to practice those vocabulary words this week so that you are ready for the quiz that's on Friday, so that you're very fluent with those words. So when we get into the little bit harder stuff next week and the even harder stuff the week after that, that you're okay with that it won't be that bad for you. But matter, anything that has mass and takes up space. The reason why I need you to know that is you'll notice every single definition that we have. A form of matter with a definite shape. A form of matter that doesn't have a definite shape. A form of matter that doesn't have a definite shape or take up a definite amount of space. It's just a word that's going to show up a lot. It's probably not going to be a question on the test. What is matter? I doubt it. If I can find it, I'll put it on there, but that would be too easy. But it's because it's in every single question, I need you to know what this word is so that somebody doesn't raise their hand during the test and say, what does this mean? What does matter? Right? Because that's not how we want to do that. Matter. Anything that has mass and takes up space. All right. It's all good. I've learned now. All right. Volume. Now you'll notice I didn't write volume on the anchor chart. I'm not really writing volume down on our anchor chart in here. I'm not putting it in our notes, but it is something that you do need to know. But you all just finished a volume project fairly recently, right? Not too long ago for Miss Tolick, Volumeville. You guys did that? And you had to find how much space your buildings took up. Volume, how much space something takes up. Again, Emma, I don't even have it written like that, but you can say it like this. A state of matter with a definite shape and a definite volume. Or I just say how much space it takes up. I changed it to the definition because if I start saying it has a definite shape and a definite volume, then kids get really confused. But if I say how much space it takes up, they understand. But that doesn't mean they won't put it that way on a test. So if you see the word volume, you know what volume means, how much space something takes up. Almost every single one of these definitions has this next word, shape. The form or the outline of an object, right? A desk has a definite shape. Water does not have a definite shape. It takes the shape of its container. Gas does not have a definite shape. It can and will fill up a container. I could put a gas into a balloon, but then I could also take that exact same balloon and have a big long balloon like this and twist it all around. All of a sudden I've got a dog, right? Different shape, right? I mean, you can change the shape of that gas and move it around because the molecules are so far apart, it can be moved around easier than we can move the molecules of that desk because those are too close together for us to do anything with. All right, 3 states of matter for now. Hey, and this is going to be on film, so like nobody in this class can deny it. Don't you dare go to the middle school and say, Mr. Bullens told us there's only 3 states of matter. I never said that. I said we're studying the 3 states of matter for now. I know you will get into plasmas next year. I've seen Grace and Caroline's homework. It talks about plasmas. We don't need to worry about it this year. Solids, liquids, gas. You keep building as you go through school. You'll get to that stuff later. It is a lot of fun. It is very interesting. We just don't get to do that in 5th grade. We're going to start off today with solids. Solids, a form of matter. It has a definite shape. It takes up a definite amount of space. It has a very fixed volume is the way they might put it. Solids. A form of matter. It has a definite shape and it takes up a definite amount of space. And for each of these, I have been drawing a picture, as you can see on the anchor chart behind me. I'm drawing a cube, and these little dots on the inside are representative of how close the molecules are. And I'm going to be honest with you, I'm probably even doing it a disservice with this, because I really shouldn't see any space in between these. But if I just color the whole thing in black, you won't realize that I'm putting a bunch of molecules together in here. Well, you can, but I do need you to realize that there's molecules in there. If you leave a little bit of spaces in there, I mean, again, this is probably not the most solid of things. I know in a few minutes this guy's going to talk about a kiwi. I mean, a kiwi is kind of squishy, right? That might be like this, but it's still a solid because it has a definite shape. It takes up a definite amount of space. Even if you put the kiwi inside of that container that I have sitting on the table right there, it's still going to retain the shape of a kiwi when I put it inside of there, whereas if I pour water into that, it's going to take the shape of its container. I'm just letting you know, like, the molecules in this need to be very, very, very close together. I'm not going to sit there and draw dots all day long to show you the molecules of a solid, but a solid is a form of matter. It takes up a definite amount of space and has a very definite shape. All right, so we've talked about matter, anything that has space, anything that has mass that takes up space. And the first form of matter we said is a solid. A solid has a definite shape. And the reason why it has a definite shape is because the molecules are so close together that it's not a lot of room for it to move around into something else. And it takes up a definite amount of space. We'll have to skip over the video for now, but we'll come back and watch that as a class later on. We're going to move on to liquids. Liquids, another form of matter. It definitely takes up a very specific amount of space. There is no way I could take this giant pitcher and fill it all the way up and go over there and pour it into, all of it, into any of your water bottles. None of your water bottles hold, I don't even know how much is in here.
Half liter, 1 gallon.
2 liters,
1 gallon.
3 liters, maybe even 4. I mean, that's way bigger than what you guys have. Liquid. Now, liquid is very different. There is no way that I can run through that desk. I can't run through the wall, and I can't stand on top of this desk and dive into the floor. Now, I mean, I could try diving into the floor. I have a feeling you would all laugh at that, but I'm not going to go anywhere. All that's going to happen is, like, my foot is going to touch the back of my head. I'm going to look like a scorpion, and I'm going to be out of work for a long time, right? Because it would kill me. Like, I can't do it because the molecules of the floor are too close together. However, when I jump off the diving board and I go into the water of the pool, I am able to move through the water. I feel it around me. I feel the water around me. And don't lie, you've all done this. When I try to run in the pool, I feel the water, right? I feel it going around my body. I feel the molecules, but I'm still able to move through it, but not nearly as fast as we can move as we're outside. We're still moving through molecules of air, a gas, which we'll get to in just a moment. But again, it's a little bit different when you're going into water because the molecules are much farther apart, and you are able to get through those spaces very easily because they just move and they flow over each other because it is a fluid. All right, so we got solids, we got liquids, and that brings us to another video that we got to watch as soon as this is over, and then we'll stop. For notes for today, we're going to stop with gas. Gas, if you notice, even in the picture, the molecules are very, very far apart. And the cool thing about gas is it definitely has mass, but it does not have a definite shape. and it does not take up a definite amount of volume. It doesn't have a definite shape. Because again, I can blow air into a balloon and I can squeeze that air all the way into the end of the balloon and it'll be fine as long as I don't pop the balloon, and I can let it go and it'll go back up into the balloon just fine because I can move that around. It doesn't take up a definite amount of space. Now when I'm looking at gases, again, I just kind of think about like being like outside or inside versus a pool. Look how much further apart these molecules are. Like there's so much space in between those that I would be able to move around very freely if I needed to in a gas, because the molecules are much further apart. I do this with my hands a lot in class. Solids, the molecules are very, very close together. Liquids, you're starting to flow a little bit. There's some space in there for things to move. And then gas, they're like really far apart and typically really moving, because a lot of things, it has to do with how much heat you have. Ice, pretty solid. It melts, it turns into water. Water heats up, it turns into water vapor. That's pretty much how that goes, and as far as that goes. But again, solids, liquids, and gases are our three things for the people at home. That's all they really need to know. They'll have to catch up with these videos when they get back.